The difference of squares strategy helps you factor out or simplify and expand certain types of expressions. And a difference of squares is when you have one value that is a square, such as a squared, we'll use that to represent right now, and you're subtracting another squared value from that first value. So you have an expression of the format a squared minus b squared. And you can easily factor it out to an expression such as a plus b times a minus b. And let's double check and make sure that this actually makes sense and works by using the distributive property to see if this expression right here turns back into a squared minus b squared. So a times a is a squared, a times negative b is negative ab, then we have b times a is positive ba, which is also the same as ab, and b times negative b is negative b squared. And then we can see if we combine like terms, negative ab plus positive ab is going to cancel out, and we are left with a squared minus b squared, which was our original expression. Let's try a few examples. Let's see which of these indicate a difference of squares and can be factored using that formula. X squared minus y squared. X squared is a squared value and so is y squared, and we're taking the difference, so we should be able to factor these out to equal x plus y times x minus y. Over here, we have x squared plus y squared. This is not a difference of squares because even though both of these are squared quantities, we are not subtracting them from each other, so we can't use our pattern from above to factor those. 16r squared minus 25. Well, r squared is a squared value, 25 is the same as 5 squared, and 16, this coefficient here, is also a squared value. So even though we have a coefficient for r squared, we can still use our difference of squares to factor this out. This will turn into 4r plus 5 times 4r minus 5. And then last but not least, we have r to the fourth minus x squared. Well, x squared is a squared value. What about r to the fourth? R to the fourth is also a squared value. R to the fourth is the same as r squared squared. And it is a difference, so we can use our difference of squares pattern over here. This will turn into r squared plus x times r squared minus x. And if you want to double check any of these to see why it works, you can use your distributive property to see if the factored version will end up equaling the original version as well.